Hello guys, welcome to another video, and in this video we are going to go over implementing DMVPN, and in this configuration we are going to configure a DMVPN Phase version 3. In Phase version 3 we are going to be able to build hub and spoke to spoke on IPv4 only. We're not going to do IPv6, and we might also, if we run into problems, we are going to do some DMVPN troubleshooting. So let's go ahead and start. And here's my lab that I put together. It took me a while, but I put it together. And as you can see right here, we are going to have the Kirk headquarters. This is a company that acquired three more companies, and the companies want to build a hub to spoke communication and also a spoke to spoke communication, or a tunnel, or a DMVPN tunnel. And since they want to do hub and spoke to spoke, we need to configure either Phase version 2 or Phase version 3. But we are going to be configuring Phase version 3 for this video. And as you can see, when we are done configuring and with all that, we should be able, from this PC, we should be able to reach Kirk Web, this website right here. From this PC, we should be able to reach this website right here. And also, we should be able to reach in this website over here. And this um, PC should be able to reach in this headquarters website right here. And the company that I just came out with this name, Kirk. That's going to be the name of the website that I'm using, or that the company that we are configuring for. So let's go ahead and start with this configuration. And also, I always like to start from the um, from the hub. So the hub is going to be this Kirk HQ. So we are going to start from here, and I have configured all the IP addresses for all the interfaces, and also all the websites and all the computers have their IP address as well. So let's go ahead and start with this configuration. And the first thing that we need to do is we need to go ahead and configure, since we are going to have an encrypted DMVPN tunnel. Hub to spoke tunnel is going to be encrypted. Spoke to spoke tunnels are going to be encrypted, and we are going to encrypt this using IKE version 1. Okay, so let's go ahead and start with that configuration of IKE version 1. And the first thing that we need to do is we need to do a crypto ISACamp, and we need to create a policy. And we are just going to call this policy number 10. And in this policy, we need to provide the authentication method, the encryption method, also the um, hashing algorithm, and Diffie-Hellman group number. So let's go ahead and start with that. Authentication is going to be a pre-share key that we're going to be using. Encryption is going to be 3 DES. And this needs to match on all the spokes router. This needs to match, or we won't be able to form that encryption or that IPsec tunnel. So we did authentication, encryption. Now we do the hashing algorithm, which is going to be, let's just do MD5. And the Diffie-Hellman group number is going to be 2. After that is done, we need to go ahead and create a crypto ISACamp. Uh, ISACamp. Uh-oh, what is the key? There we go. ISACamp key, and we're going to call this key DMVPN key. And the key is going to authenticate these IP addresses, which means that we are going to authenticate any IP address. So that means that we are going to be able to authenticate with this key with any IP address. So we're going to be able to authenticate with Kirk2, Kirk3, and Kirk4. Okay, so that's what it means, any IP address. And this is done. So now what we need to do is this is phase version 1 of IKE version 1. So now um, what we need to do is that we need to configure IKE version 1 phase 2. And phase 2, we need to create a transform set. So let's go ahead and do that. Crypto IPsec transform set, and we're going to call this transform set tset. And we need to provide the encryption that we're going to be using. It's going to be AES256, and the hashing algorithm to provide data integrity is going to be SHA with HMAC. And the mode is going to be a transform mode. After we do that, we need to go ahead and create a IPsec profile, and we're going to be calling this profile DMVPN profile. And over here, what we need to do is we need to attach the transform set that we just created, which is called tset. There it is. So give me just 1 second. All right, so we are done with IKE version 1, phase 1, and phase 2. Since we're going to be using the same configuration for Kirk 2 and Kirk 3 and Kirk 4, what I'm going to be doing is I'm just going to copy and paste this IKE version 1 and IKE version 2 configuration. So we can do show run section and do crypto. And from here, we're going to be able to see everything we configure. IKE version 1 and IKE version 2. So we're going to copy this configuration. We're going to go to Kirk 2 and we're going to just paste it over here. We're going to go to Kirk 3 and we're going to paste it over here. We're going to go to Kirk 4 and we're going to paste this over here. So now all the routers have IKE version 1, phase 1, and phase 2 configured on all the devices. So they all have the same parameters as you can see because I just copy and pasted from Kirk HQ. So that's good. So after that is done, we need to start configuring the tunnel, the DMVPN tunnel that we're going to be using. So let's go ahead and start with that. We need to do an interface tunnel. It's going to be tunnel 0. We need to provide an IP address, which is going to be 192.168.1.1, 255.255.255.0. And as you can see right here, the tunnel IP address for each one of them is the tunnel IP address right here for this one, for this one, and for this one. Okay, so let's press enter. Now let's go ahead and do it IP, NHRP, network ID is going to be 10. Then we're going to do no IP split horizon, EIGRP 10. So what this does, the no IP split horizon, is that by default, EIGRP does split horizon. And that means that if we learn a route from this interface, right, we are now going to share it back out. So if we learn 10.10.2.1, we're not going to share it with the rest, but we want to share it, and therefore we need to do no IP split horizon. Because if we learn this IP, right, we're not going to share it with Kirk 3 or Kirk 4, and if we learn this IP address from Kirk 4, we won't share it with Kirk 3 and Kirk 2, but we want to share it, and that's why you want to do no split horizon. Okay, and after that is done, what we need to configure is do a this is going to be from the hub. We need to do a IP NHRP map multicast, and it's going to be a dynamic multicast. And what that means is that the multicast that we get, we are just going to set it dynamically. So multicast packets are packets coming from EIGRP. All right. So IP NHRP map multicast dynamic, IP network ID. We need to do the source, which is gigabit 00, and that has been configured. So we did the no split horizon multicast network ID. Now we need to do an IP redirect or IP NHRP redirect. And what this does is that since we're using Phase version 3, IP NHRP redirect, what happened is that whenever the spoke sends those NHRP requests, what it's going to do is it's going to redirect to the spokes so they can um, so they can um, create those spoke to spoke tunnel themselves. So the headquarters is not going to help, it's not going to create those spoke to spoke for them like in phase version 2 or DMVPN phase version 2. What's going to happen is this, what it does is it just sends it to the spoke that they want to build the spoke to spoke with. Okay. Hopefully I explained that right. If I did not, just leave me a comment below and I can explain it a little bit better for you guys. And then we can do a tonal mode and then GRE multi-point. And this means this tunnel mode GRE multi-point means that this tunnel over here is going to be multi-point, and it is multi-point because we are going to have multiple connections with this source IP, with this source interface right here, right? Because we're going to build a hub to spoke with Kirk2, Kirk3, and Kirk4, and therefore it's going to be a multi-point tunnel. All right, so after that is done, we need to do an tunnel protection, IPsec, and profile, and we need to attach that profile that we just created, which we named DMVPN profile. And we're going to attach that IPsec configuration with IKEv1 that we just did. And now you can see that ISACamp is on. And we can do a show IP NHRP, and we don't have any NHRP tunnels yet. So let's go ahead and configure the first spoke first so we can see that. So let's go ahead and go into interface, tunnel. And actually, I forgot to do something like I always do. Let's do a config t router EIGRP 10. And this number, this autonomous number, needs to be the same as the one that we configure right here. No split horizon EIGRP 10. So that's correctly. No auto summary. Network. We need to configure a couple networks, and one of the networks is going to be the tunnel network, and the other network is going to be my internal network. There we go. So we can advertise that we have this network right here, and we advertise that this is our tunnel. Okay, that is done. Let's go ahead to Kirk2, and let's go ahead and configure the IP address first. 192.168.1.2. That's correctly. /24. Let's do a IP NHRP network ID 10 IP NHRP NHS, and what we're going to tell is that we are telling this um, this router which one is the next hop server, and the next hop server needs to be the I'm sorry, it needs to be the hub IP address, or the hub tunnel IP address, which is 192.168.1.1. And now we need to add it. We need to create a map, and we are going to tell which one is the NBMA IP address. And the NBMA IP address is this IP address, which is the IP address of gigabit 192.1.1.10.1. And we are just going to call this multicast because it is going to be the multicast IP address as well. And we are telling it that the next hop is this one, and the map to reach this tunnel is going to be this NBMA IP address, and it is also multicast. Multicast means that whenever we create a like an EIGRP or OSPF or IGRP packet, it's going to send it to the hub, which is mapped to the next hub server, which is this one right here. Okay, this is done. Then we can do an IP NHRP shortcut. And this shortcut works with the IP NHRP redirect that we created on Kirk HQ. And what that does is that it's like switching to discover to shorter paths to a destination network after receiving an NHRP redirect message from the hub. And this allows the routers to communicate directly with each other without the need for an alternative hub, not a hub or a hub. Okay, so what I'm telling it is whenever we get that IP NHRP redirect message from the hub, I want to communicate directly with that router. So if I send a packet that I want to communicate with 10.10.4.1, and the hub is going to know that it's not in its network because its network is 10.10.1.1. So if we get Kirk2 is trying to reach 10.10.4.1, what the hub is going to do is going to send that redirect message to Kirk4, and then Kirk4 is going to directly communicate with Kirk2, and it's going to form a spoke-to-spoke tunnel. Okay, so that's how it works. Now let's do an IP, or actually a tunnel source. Tunnel source is gigabit 00, and then the tunnel mode GRE multipoint, because we're going to have a multipoint connection from Kirk2. We are going to have a multipoint connection because we are going to form a hub to spoke with the hub, and a spoke to spoke with the other routers. All right, so you can see that the interface came up, and now we need to turn on the we need to turn on the ISACamp configuration or the ISACamp um yeah the IPsec IK version 1 with IPsec with the IPsec tunnel with with IK version 1. So what we need to do is we need to attach a profile so we can encrypt everything. So tunnel protection IPsec profile. We attach a profile that we created. Then ISACamp is now on. And if we go to Kirk HQ, we will end it. Before we do that, let's go ahead and do router EIGRP 10, no auto summary. We need to add the network um, of the tunnel, and then we need to add our internal network, which is this one, right? 10.10.2.1.0 right here. And now we form a EIGRP network adjacency. Now we can go to Kirk HQ, and if we do a show IP and NHRP, you can see that we have created a tunnel, and the tunnel that we created, um, it is coming from 192.168.1.2, which is the tunnel IP address, and the MBMA address is 192.1.20.1, and it is a dynamic tunnel. But if we go over here, show IP and NHRP, we can see that the tunnel type is static, and that means that we manually created this tunnel, and we did because we mapped it. We set at IP and NHRP, NHS, and the MBMA, and we set multicast, and that means that it is a static map. We did not do this one from the headquarters, right? It was just created dynamically. Okay, so that is done. Let's go ahead to move on to Kirk 3, interface tunnel 0, IP address 192.168.1.3. 0, IP NHRP, network ID 10, IP NHRP NHS 192.168.1.1, and BMA 192.1.10.1, and then multicast. Good. Then we do a mode or tunnel. Let's do a tunnel source first. Okay, GABA 00, tunnel mode, GRE multipoint. Then we do IP NHRP and NHRP shortcut. And so we did all of that. We did the NHS, network ID, shortcut, source, mode. Okay, and now what we need to do is we need to turn on IPsec, and we do it like this: tunnel mode IPsec profile. Tunnel protection IPsec profile. There it is. And now ISACamp is on. ISACamp is on. Let's go ahead into Kirk headquarters. If we do a show IP and HRP, you can see that now we have two tunnels and they were created dynamically. We can see 192.168.1.3, which is the Kirk 3 that we just configured, and it was created dynamically. And the MBMA IP address is 192.1.30.1. Okay, good. All good. And now let's go ahead and do router EIGRP 10. And we are just going to start with no auto summary. We need to add the networks, the tunnel first, and the network 10.10.3.0 to show IP and HRP. And we can see that we have a tunnel created, statically created, to the hub, which is 192.168.1.1, and the MBMA IP address is 192.1.10.1. So everything is working. And also if you go over here, if you do a show IP, IRP neighbors, which you see Kirk 2, and Kirk 3. and via the tunnel interface. And since they are going via the tunnel interface, that means that everything is going to be encrypted, right? Because we attached that profile there. Now let's go ahead into Kirk 3. Do interface tunnel 0 IP address 192.168.1.4 255.255.255.0 IP NHRP network ID 10 IP NHRP NHS MBMA multicast IP NHRP shortcut tunnel source gigabit 00 tunnel mode GRE multipoint. So network ID, IP shortcut. Oh, that is good. You can see that the tunnel came up. Now we need to do a tunnel protection IPsec profile. We need to attach that profile right here. And now ISACamp is on. And if you go ahead into Kirk headquarters, you can see that we have received a new tunnel. And if we do a show IP and HRP, you can see that we have 3 now. 1 to Kirk 2, 1 to Kirk 3, and the last one to Kirk 4. And you can see that it was created dynamically as well. And now let's go ahead and end that configuration. IP EIGRP Autonomous System 10. No other summary. Network 192.168.1.0. Network 10.10.4.0.255. Okay, so that is good. Configuration is all done. You can see that we have a new neighbor. If we do show IP IGRP neighbors, you can see that we have 3 neighbors. One is to Kirk 4, Kirk 3, and Kirk 2. So now we have a connection, and all is good. If we do show IP routes and just EIGRP, you can see now that we have access to 10.10.2, Kirk 2, 10.10.3, Kirk 3, and 10.10.4, Kirk 4, and this is via the tunnels. And since they are via the tunnel, you can see right here tunnel 0. That means that every time we try to reach these networks is going to go via the tunnel. And since the tunnel are encrypted, everything is going to be encrypted and is going to provide data confidentiality and data integrity, anti-reply, and all that good stuff. So nobody can just sniff on your network and see what you're doing whenever you are trying to reach those networks, right? So we are done, and what we could do to verify those IPsec configuration and to verify ISACamp or IKEv1 Phase 1, you can do a show crypto ISACamp SA, and you can see this is for IKEv1 Phase 1. You can see the destinations all to the hub and the sources where they're coming from. 40.1, Kirk 4, 30.1, Kirk 3, and 20.1, which is Kirk 2. And if we want to if we want to verify the IKEv1 Phase 2, you can do a crypto IPsec SA, and you can see right here that we are sending traffic because we are sending those hello packets from EIGRP, and they are being encrypted. Okay. You can see all of that good stuff. Encapsulating 77, decapsulating 69, and you can see that this is coming from the remote identity. This is coming from now 192.1.30.1. Okay, so this is coming from Kirk 3. And the other one that we just passed, if you want to take a look at it, 192.1.40.1, which is the remote identity of that router, it is coming for Kirk 4. Okay, so this is Kirk 3. If you keep going down, you can see the transform set, what it has set, which is ESP256 with AES and ESP with SHA and HMAC. You can see all that good stuff right here. And if we want to see the last one, which is Kirk 2, You can see that it has a lot more encapsulated packets and decapsulated packets, and that's because that was the first one that came on. So, and we have sent 119 hello packets, and we have received 116 hello packets from the NHRP. You can see the remote identity. That way you can see which one is the one that is coming from. You can see the local crypto endpoint, which is the hub, and the remote crypto endpoint, which is Kirk2. You can see the transform set configure, and you can see all that good stuff over here. Okay, so that is done. And if you do show IP and NHRP, you only have those. And if you do it from, let's start with from Kirk2 and do a trace search. And I want to ping 10.10.4.1. But before we do that, let's do a show IP and NHRP. We can see that we only have one tunnel created. But if we do a trace route to 10.10.4.1, which is the IP address of Kirk4, you can see that the first packet went through the hub and then it went straight to the tunnel. But now, since remember before we did the trace route, before we send that ping, we only had one tunnel. But now if we do show IP and NHRP, you can see that we have a couple tunnels that has been created, and they were created dynamically created. As you can see, the ones that we just that they were set, and they made a connection, as you can see, with ourselves, which is the router unique local. That this one right here, and this one is for Kirk4. It was built dynamically. You can see the NVMe IP address and the tunnel IP address. It was created dynamically, and it is the router next hop RIB. And now if we do another trace route, it's going to go straight to Kirk4, and that's because we have created a spoke-to-spoke tunnel. And since we created a spoke-to-spoke tunnel, we do not go to the hub and then to this and then to Kirk4. Since we created that tunnel, after that, right here, now we go right here. Now we go straight to Kirk4 because we created that tunnel. Okay. So now if we go into PC4 or PC, which one was the one that we just did? Kirk2. So let's go ahead to Kirk2 PC, and let's go ahead to the website of Kirk4, which is the IP address is 10.10.4.3.4.3, 10.10.4.3. It says that we are unable to connect. So 10.10.4.3, we are unable to reach that website. And let's go ahead into that website and see what's going on. And let's do an IKEv1, and we do have that IP address right here. Are we able to ping 10.10.4.1? We are. Are we able to ping 3.1? We are. What about 2.1? We are. Then what about 10.2? We are not. So let's see what's going on with this PC. So this PC, there's something going on over here. Let's do a IKEv1. It probably doesn't have an IP address. IKEv1. Yeah, we don't see an IP address. So let's configure an IP address. You can do IKEv1 interface 0 of 10.10.2.2, and this one is to say net mask, and then we do router add default gateway 10.10.2.1 or route add. There we go. Now we should be able to reach this website. There we go. So now we were able to reach the welcome to Kirk4 website. And now if we want you, I know you were probably wondering, now it's working. Let's go ahead and close it. Now you're wondering if this is being encrypted. And the way that you can do that is from Kirk4. You can do a show or not show, we can do a debug crypto engine packet. And if you do a reload, you can see that everything is being encrypted and decrypted. You can see right here because I'm reloading this website and I'm sending packets every time, and it is being encrypted and decrypted. You can see it right here. You can see it on all to stop the debugging. It's still going to keep going because it keeps sending packets and all that good stuff, right? You can see it is working the way we wanted it, right? So we have a connection right here. That's good. Um, oops, let's go ahead and go back. Let's go ahead and go back and open Kirk 2, and let's try now to go to Kirk 1 website, which is 1.3. So 10.10.1.3. There we go. And now you can see welcome to Kirk headquarters website. And if you want to see if the packets are being encrypted and decrypted, you can do a crypto or nah, debug crypto engine packet. And you can do a reload. And if you reload, you can see that everything is being encrypted and decrypted over here, all the traffic that's coming through it. So it is working the way we wanted it. Okay. So as you can see, right now we have a connection between all of them, between Kirk 2, Kirk 3, and Kirk 4. And if you want to build more spoke to spoke, let's go ahead into which one was the one that we did. Or let's do a show IP NHRP. You can see that we have a local. Oh, not a local. This is the remote one for 10.10.4.1 or to the 10.10.4 network right here to Kirk 4. So we have created two for them. Now let's do a trace route and we want to ping Kirk 3, right? And let's ping 10.10.3.1. You can see the first one went through the um, first one went through the hub because we did not have that spoke-to-spoke communication with Kirk 3. But now if we do a trace route again, you can see that since we built the um, the the spoke-to-spoke communication, you do show IP and HRP, and now you should see that we have two new tunnels. The one is for 192.168.1.3, Kirk 3, and the other one is for 10.10.3.0, which is also in Kirk 3. And we also have one for 10.10.4.0, Kirk 4, and 192.168.1.4, which is Kirk 4, right? So you can see that we are dynamically building um, tunnels, and in those DMVPN tunnels, we are also encrypting all the data that's going through between Kirk 2, Kirk 3, Kirk 4, and Kirk headquarters. Okay, so I believe this is it for this video, guys. I hope you guys enjoyed this video. I hope you guys learned something about DMVPN Phase version 3 and with IKE version 1, right? And if you guys enjoyed this video, why don't you just go ahead and go to my Twitter account and follow me on Twitter at CCNA Daily Tips. And if you don't have a Twitter account, go ahead and create a Twitter account and then follow me on Twitter. And also subscribe to my channel. Thank you guys for watching. I'll see you on the next one. And I love you guys. Bye bye.